Hello everyone, my name is Sushanta Sinha. I will be taking a session on securing global routing. This is part of a chapter initiative of ISOC Kolkata, Internet Society Kolkata, and as the initiative of global learning of ISOC. So today I will be touching upon various aspects of MANRAS, mutually agreed norms for routing security. So for next half an hour, we'll talk about some of the security threats and some of the steps towards addressing them through manuals. Now, before we talk about MANRAS, uh, mutually agreed norms for routing security, uh, we first understand what is routing protocol, right? So as you see in the figure, this is how your internet architecture looks like, right? So this is how you connect from your home computer or your office LAN to access web resources across the internet. Let me move that something down. Okay, so this is how you connect from your residential subscribers, from your office LAN to the backbone ISP, right? Now, most large companies have their own dedicated backbone, right? Connecting various regions. In each region, the company has a point of presence. The company has a point of presence we called POP, right? Which is the this open circles, right? And the POP is a place for local users to access the company's network. Now, there are several high-level networks which connecting to each other through network access points, or you call it as NAPs. Understood? So in this, in line with that, we have interior routing protocol and exterior routing protocol. These are the two types of routing protocols that are in use. So interior routing protocol designed for networks that are controlled by a single organization, and it is mainly used for routing within an autonomous system, or AS, commonly known as AS. An autonomous system, AS, is managed and supervised by a single entity or organization, and it has some routing logic and common routing policies. It is assigned by globally unique 16-digit identification number known as the AS number or ASN by the Internet Assigned Numbers Authority, IANA, and through regional internet registries, RIR. So commonly we use protocols are RIP, OSPF, ISIS, EIGRP. Now, what is RIP? Routing Information Protocols. This is one of the oldest distance vector routing protocols which employ the hop count as a routing metric. Hop count, number of hops. OSPF is the open shortest path first. It finds out the shortest path and takes that as a routing path. And this is another routing protocol. ISIS is intermediate system to intermediate system, commonly known as ISIS. Another routing protocol. Enhanced Interior Gateway Routing Protocol, EIGRP, is an advanced distance vector protocol, routing protocol, and that is used on a computer network for automating routing decisions and configuration. The protocol was designed by Cisco Systems as a proprietary protocol and available only on Cisco routers. Now, all these I discussed is about interior routing protocol. So there are also exterior routing protocols, and most commonly used exterior routing protocol is the BGP, Border Gateway Protocol, and it handles routing outside an autonomous system. So routing between autonomous system is the BGP. It gets you from your network through your internet provider's network and onto another network on the internet, right? So one AS to another AS, and it works commonly. It's commonly used between ISPs or between ISP and an enterprise, right? So it's between one ISP and one enterprise. And BGP is a path vector routing protocol, right? So this is how it works. Okay. Now if you go to the next slide, little bit of BGP, the global routing security. BGP was designed for simplicity and ease of deployment in the 1990s. Okay, it was primarily built on trust. Okay, it was based on trust, having no inbuilt security as such. Through BGP, each AS autonomous system announces its autonomous system number, the ASN, and the prefixes associated with it. There is no protocol to determine whether the advertised ASNs or prefixes usually belong to the network that is advertising. It was only built on trust. So this lack of routing verification has led to both malicious and accidental routing problems. Common routing security problems that we face because of this is prefix hijacking, IP address spoofing, and route leaks. Now we will cover each of this a little in detail, and we'll show you how it happens. The BGP stream is one portal which shows some data about the possible BGP hijack and BGP leaks over few years, and the number is growing. You see it as data from 2015 to 17, so 17 June to 17 December 2017. And if you see that even latest data, it is still up. It actually maintains on a daily basis how this BGP leaks or BGP, this hijacking is taking place. These are some of the, I would say, incidents that comes into news, and all this. Uh, I would say if you keep your eyes and ears open, you will know how such security flaws could create havoc, right? It creates a headline sometimes, but for numerous cases, it remains as undiscussed and unpublicized. I can show you a link from YouTube to understand how it has happened once the Pakistan knocked down YouTube for some time. If you can. Okay, so as you understood that these are the events that has taken place, and numerous such which comes into paper, but there are many which are not even discussed and come in and makes a news. So if you go to this BGP stream, in fact, it also captures all the data that has happened, all the threats that is happening. I will show you also through the screen. But if you see one events which is taken place on 30th of May of BGP leak, if you go to the details, it will show you how the session numbers, how it flows, from where, what time of the day, what exactly has happened, when it was announced, and how the path has changed, and how it is withdrawal. Every details you can see this through the site. So if I can show you one such thing like this, so it's like it's happening like this. We can it shows what are the outages, what are the possible hijack, what are the hijacks happen here. There is a BGP leak, and this is all real time, and you can get all the details if you're interested. So the track that, and there are numerous such things that happen. Okay, so if we analyze all those kind of threats that is coming up, we know there are primarily these three areas that we will cover today and happening very commonly. One is the prefix hijack, and there is route leaks and IP address spoofing. For prefix hijacks, it is disguise itself as another network, and route leaks is basically propagations of routing announcements beyond intended scope. For routing, it takes a longer path or a different path. A creation of IP packets with a false source IP address. We'll briefly touch upon each of this in next few slides to at least understand what exactly are those. Let us take the next one as the uh, prefix hijack. If you see the diagram here on the left, it shows that what happens when AS15169 announces its prefix 8.8.8.0/24, and the traffic from AS564501 comes as the normal route, and it finds here, right? Because it is announcing its prefix, right? Now, if you do not have any prefix filter in place, the attacker can exploit BGP and announce the same prefix. So if you see this diagram here, diagram 2, this is the one which is announcing it. So the diagram 2 shows how prefix hijacking takes place. You can see AS64502, this one is announcing prefix 8.8.8.0/24, which is actually owned by this one, AS15169. So because they are announcing this, the traffic is hijacked here. It is not reaching here, it is reaching here. So this is one of the common threats that is there because of this improper filtering at the source. Okay, we call the prefix hijack. Now, if you take the next one called route leak, how it happens is, and if you see the diagram on the left, it shows that when AS15169 announces its prefix 8.8.8.0/24, and the traffic from AS this 564502 coming up in this path. This is the normal path, right? Normal traffic. It announces here, and it comes here. Now, sometimes what happens is, without again the prefix filter implemented, route leaks can occur like this. From the diagram 2, it shows that the route leaks takes place. It can occur when a customer announces route they learn from a transit provider to another transit provider. Okay, so from this transit provider, uh, from AS64502 being directed to AS5169 via AS64500, AS64501, and then an ASB. So instead of taking this path, this is the normal path, it actually takes this path. So it's unintended or intended, it is actually touching through a different ASS numbers or different routes. So this is how this traffic leak, this is the leak traffic, follows. So this is another threats or another uh, security clause that we can see if we do not have this prefix filter. If you go to the next one, which is called the IP address spoofing, what is this? It is the practice of originating IP datagrams with source addresses other than those assigned to the host of origin. Okay, so this is the one where this actually it is coming from, it is showing this 203 .0.113.1. It is showing, but it is actually coming from 192.0.21. Okay, the spoofing can be exploited in various ways. The most notably it is it executes DDoS reflection amplification attack. So the problem is this series 192.0.21 is not the source. It is a source, but it is actually showing as 203.0.113.1, and which is the wrong one. Okay. Now, how it actually works? It works in the mode of reflection and amplification attack. So it first have a reflection. It occurs when an attacker sends traffic to a victim via a third party. So it's basically not the original one; it's the reflective sites. Okay, so use a third party. And amplification is achieved by a small queries resulting in much larger responses. Right. So open DNS resolves and NTP servers are commonly used as reflectors or amplifiers. So these are the three common threats, and this is how it happens here. So if I take the summary of all these three events, this prefix or route hijacking, route leak, and IP address spoofing, um, the repercussions are: for prefix hijacking, the packets are forwarded to the wrong place and can cause a denial of services, attacks or traffic interceptions. And the solution is stronger filtering policies. Same thing for route leak, can be used as a traffic inspections, and stronger routing filtering is what is necessary. For IP address spoofing, the root cause of reflection of DDoS attacks and source address validation. So if we can at least take some kind of a care of stronger filtering policies and source address validations, we can avoid these situations, which are very common, and people do not give much focus on that. And Mandras always recommends that if you come into this network and follow some routing protocols rules and standard practices, you can avoid those situations. So it defines 4 concrete actions that network operators should implement. Okay, so it's boiled down to these 4 critical actions: global validation, filtering, anti-spoofing, and coordination. So if you can at least focus on this 4, you can avoid many such unintended, embarrassed situations. Global validations: in order to facilitate validation of routing information on a global scale, network operators must publish their routing information so that other parties can validate it. Okay, so globally it can be validated. In order to prevent propagation of incorrect routing informations, network operators must ensure the correctness of their own announcements and announcements from their own customers to adjacent networks with prefix and AS path granularity. Right. So this is what does the filtering ensures. Anti-spoofing: in order to prevent traffic with spoofed source IP addresses, network operators must enable source address validation for at least single home stop customers networks, their own and end users infrastructure. If you can do that, you are relatively safe. And because this is a globally connected system, so coordination is very important, and In order to facilitate global operational communications and coordination between network operators, they must maintain globally accessible and up-to-date contact information. Right? Again, it is boiling down to these four critical areas that you need to focus on, and Manders recommends that, emphasizes on these four areas. Okay, we'll touch upon some of these examples. So, this global validations in situation 1 and 2, an attacker announces the prefix of another network, which is an AS number X is announcing prefix AS64501. Okay, X501, which propagates and accepted by neighboring ASs as A, as B. It causes traffic that is destined to AS64501. This is how it is being announced. Okay, to be directed to the attacker AXs, right? So it announces this one, and it is announces to ASB, and ASA knows about it, and this is how the propagated announcement comes to. If AS64501 publishes a network routing policy, okay, if this one has is published this network routing policies, ASB, other networks, they are able to look up AS64501's routing informations here to establish the true owner of the announced prefix. It is not this one, so they will actually divert the traffic here and not here. So when the request comes from here, okay, it goes to the right owner because this is already published here and it can be validated, right? So this origin validation is one of the important part of this global validation, right? This is the first one that Manders talks about. And participants are required to publish the network routing policy and other associated routing informations to IRR, Internet Routing Registries that we have shown, and also on RPKI, the Resource Public Infrastructure Repository, and peering key. So this is how, if we publish, people can go back, validate, and ensure that no attacker can deroute your request. Okay. Filtering, we show that how because the filtering was not in place, you are under the threat. So specific prefix outbound filtering of your network to peers and upstreams that is required, man recommends, and specific prefix inbound filtering from customers. These two are mandatory and it is required for you to be safe. And it also recommends that specific prefix inbound filtering of peers to your network. Okay, peers to your network. There is also some kind of a bogus fake IP addresses, and the bogus filtering in practice is also there, and which basically addresses this bogus or fake IP addresses of the computer network. There are different tools available in the market, and to work with these IRR policies, IRR toolset, BGPQ3, IRRPP. Okay, that ensures that your filtering is done properly. Now coming to the third one, the anti-spoofing of the start of the fourth one, the four major areas, and it has been done using ACLs and URPF. Commonly used anti-spoofing techniques are access control lists and URPF, unicast reverse path forwarding. ACLs are used to filter network traffic by controlling whether the routed packets are forwarded or blocked at the router's interface. They are configured to allow specific address ranges and deny all others. So if it is meant for the service provider customer's allocation block is 191.51.100.100.0/24, then ACL would only permit packets with source addresses from this one and deny packets that originate from a different source addresses. As example here is 192.0.2.1. So it will not allow because the ACS is blocking that. Okay. URPF is defined in RFC 37 request for comment 3704, and it states that traffic from unknown invalid networks should not be accepted on interfaces from which they should never originated. So URPF works in the four modes. They are in either in the loose mode, feasible path, VRF mode, and the strict mode. Okay, and there are some examples that are given that for single home stop computers, stop customers, it's recommended for strict mode, and multi-home stop computers, customers, it is the best for feasible mode of URPF. It's often implemented as the edge of the network where the customer servers and clients are connected, so that wherever the entry points are, you put those checks. Okay, so incoming packet source, it doesn't allow if it is not in the list, and so that you protect all those kind of spoofing of the source address. The fourth one of this four parameters is the coordination, and as I said, all this context, everything should be collaboratively published through this RIR, whose database, IRR database, peering DB, and also the company websites. So they should publish and maintain their contact information to their regions, IR, and all these things, so that anything happens, people can collaborate, find out the reasons, and get the actual information rather than somebody faking it. Okay, so again, if I go back, these are the four important pillars that can at least give you some kind of a security safety net if you follow some of the standards, routing protocols and standards recommended by managers. So in short, so it is an important step. However, it is not a one-stop solution to all the internet routing problems or the issues, but it is an important step towards a globally robust and secure routing infrastructures. So if you have a collaborative network, they follow the standard norms, they understand each other dependencies, how much they can trust, how much they can validate, then you will have a very healthy ecosystem. And today, as we speak, towards the middle of month of May, Manras have 500 such networks which are signed in, and it's definitely a process which can ensure security, and it provides a structure and a consistent approach to solving security issues facing the internet. So it is very important that when users are not that educated, they're not aware that how much threat they have when they're exchanging informations, whether it is an individual or a corporate. That's a huge stake for them if they lose information, if someone unintended entity captures those information. So this is an ecosystem, this is a group and a collaborative, I would say, structure where you can ensure that you fall back on each other, you can encase all the infrastructure available so that you can make your network secure. Now the question is why the service providers should join Mandras. It definitely gives you an edge for your, it's a competitive edge. It helps solve global network problems. It's led by examples to improve routing security and ensure a globally robust and secure routing infrastructures. So being part of the Mandras community can strengthen the enterprise security skills. As I said, it is definitely a competitive value. So whenever you say, okay, I'm part of Mandras and I have an ecosystem that ensures that your origin validation is done, your spoofing at the IP at source can be checked, and we are a system working together, because routing is not something that you can just use at your own system, right? You have to exchange data from a remote data points, and you have to take help from other networks. Okay, so So this is very important. To lock in from a connectivity provider to a security partner, it is you should not be seen as just a service provider, but you're also part of uh, uh, play the role of a partner, and you're part of the business objectives or individual interests that the user has. So information feeds and other add-on services may increase the revenue and reduce customer churn. So if I have trust on your system, if I know that I'm secured by using your network, I am better off, and you can have more revenues. You can have customer trust if you are part of this. So enterprises, why should they be interested for this? Because enterprises deal with huge data, right? And their confidential data, their business critical data, their individual privacy data. So if I can ensure that these organizations uh, they can leverage this security infrastructure through vendors, it's an added value for me. So Mahindra's ready infrastructure partners increase security and service reliability while eliminating common outages and attacks. Yes, so if something happens, some attacks takes place, so there is outages, so there may be recovery faster if we are part of this network and to fall back on each other's system to recover from the situation. Requiring Mandos adoption can help enterprises demonstrate due diligence and regulatory compliances. So you know that you have to go through some of this regulatory compliances because of the system. So you by following that, you're automatically taking care of some of this standards areas, gray areas, loopholes that normally pops in. Preventing traffic hijacking, detouring, and malicious traffic helps prevent data loss. As I said, this is a common problem that all the networks faces, denial of services, and it also has a reputational damage. Like if you don't take care of that, and if your network goes for outage, and you have denial of services, it is a huge stake on your reputation. So enterprises should not take that chance. Attacks and outages are resolved promptly because you have an ecosystem that can correct the data, that can give you a different recovery path, and your recovery is very faster. So Mandas provides a foundation for value-added service. Incident information sharing and information feeds can directly impact the bottom line. Okay, it impacts your revenue and the bottom line. Organizations can improve SLA compliances. So if your outages are there, you can recover fast and addresses a host of routing deficiencies by simply seeking providers that adopt Mandos. Again, for the governments, how it helps, it handles a lot of citizen data, their privacy data, there are a lot of government policies, their compliances, regulatory things. So if they are part of the ecosystem, they can ensure and they can also, I would say, impose the requirements that the government has and put them into the ecosystem. So to drive the development or adoption of best practices across the country, they can learn from others and say, okay, hey, I can also adopt this under the situations, and that will make my data secure. Encourage industry associations to develop or strengthen and promote existing voluntary codes to contact for network operators. Um, it also encourage the use of routing security as a competitive best practices. As nothing to mention about that. Encourage local industry to better convey. Yes. So if the industries under the government finds it that okay, their business informations can be secured, I'll be more interested to come and set up my things in your country, but under your government. Otherwise, I will definitely doubt that is my business viable because this government does not really give much focus on securing the data that I'm dealing with. So you lead by examples, improve infrastructure reliability and security by adopting best practices in their own networks. So definitely governments should play a vital role by coming into this mandate. Why research and education networks should join? There's a huge opportunity for taking off the problems that we have as part of the research and educating people on that. To show technical leaderships, yes, so you can stretch your technical ability to address and help the problems being sorted out. showing your technical leadership and distinguish you from commercial ISPs. You can work as an R&D cell. You can work as an expert on on this subject. Customers increasing willing to pay more for secure services to add competitive value and enhance operational effectiveness. A growing demand from customers for damaged security services. So to show security proficiency and commitment to your customers, promote vendors compliance to security focus to help solve global network problems, and the NRIANs are often early adopters of new developments. So sometimes, before someone takes up, whether it's an enterprise or a government, they want to ensure that somebody has done some kind of due diligence and proofing so that they can trust them. And this research and education networks can actually do that. They can lead by examples and improve routing security for everyone. So being part of the Mandas community, they can strengthen enterprise security credentials. So to summarize all this, so entire ecosystems are like to be built together, and the network operators have a responsibility to ensure a globally robust and secure routing infrastructure. Your network's safety depends on a routing infrastructure that weeds out bad actors and accidental misconfigurations that wreak havoc on the internet. So there are some incidents, or maybe many incidents, which are intended because there are some bad elements out there. They want to steal your data. They want to do some kind of a harm on your branding, on your reputations, and putting down your sites or having making your service unavailable. But there are also some mistakes or the errors that people do, which may be a human or a system errors by doing some misconfigurations. But if the entire ecosystem works for a common goal, they can achieve that. They can reduce those incidents. So the more network operators work together, the fewer incidents there will be, and the less damage they can do. And internet, this technology is evolving, so there'll be a lot more such situations that will be coming up. There are a lot more inputs that will be fed in, and a lot more research has to be done to make internet even secure for tomorrow. The entire technology suite has changed, people demand has changed, the usage has increased multifold, and there are various facets of um, security flaws and security incidents are taking place. So we have to deal that together, and all these entities play a vital role in doing that. So we suggest that in one way you increase your technical expertise on how this global routing works, understanding all the security flaws, understanding how do I address those uh, through this primarily these four pillars, understanding details about how actually I set up, how do I configure my prefix filtering, anti-spoofing mechanism, how do I declare, how do I validate things, join Mandras and be a part of it. You can write to Mandras NRS at isoc.org for any kind of support to get involved in the community. We can reach out and educate more and more people on this. The members support the initiative and implement the actions in their own networks. So the primary thing is that okay, you don't have to go and fix problems for others. If you can at least follow the same kind of norms, declare it, validate it the way it should be, the entire ecosystem will be safe. So do your part, and you play a very important role at this point in time. And the members maintain and improve the document and promote Manda's objectives. So my sincere thanks to Internet Society for arranging such training sessions globally. But the more such sessions takes place, the more people will be educated, and it will be beneficial as a whole the internet community. Okay, and my sincere gratitude towards the faculty who took some time out and facilitate uh, you know training for us, Mr. Ronald Kennedy. His email ID is here, for taking our sessions and providing a lot of reference materials. It has opened up so many opportunities to learn and fix things and go into details. It raised interest on really lot many things happening around which we're not aware of, and it's a fantastic job that he did. Again, my special thanks to Nancy and the Priyatos, our ISHA Kolkata chapter coordinator, and the entire ISHA Kolkata chapters, their OBs, chairman, vice chairman, everybody, and members community for promoting this. And we look forward to more and more engagement and exchanging our views, exchanging technical expertise, and see how we can build and make internet safe for tomorrow. Okay, so thank you all. We stop here and let us look forward for more such interactions in future. And if you have any queries, any doubts, or anything that you need from us, do contact us to iShock or iShock